And welcome back to the next week. In this week, we're going to create the additional elements. So you can see that this our scene we left with an explosion, but I renamed it to additional elements, and we can remove this explosion, by the way, because we really don't need them. If we want to use the explosion to drive some elements like sparks, we can simply download the explosion cache, and we don't need to keep all those dop networks here. Also, I can remove the ocean because I do need it also. We can simply remove geometry, but just in case we need some kind of explosion animation or maybe some geometry from the model we can left here, because we already have the result of our simulation, so all of our fragments and geometry we have in our BDC. So we begin with the debris, and mainly for many of our additional elements, we're going to use our RBD simulation as a source. So we create the VDB here using the, let's dive in here, using our shift render cache. So this is our all geometries from the ship, and that's what we have from our RBD simulation. So we convert this into VDB using explosion, and what I want to do, I want to copy this file cache and create NAS geometry. So I want to separate my sources here. So let's name this source from frags. Can disable it and paste our geometry here. So come on. What we want to use as a source. I want to separate my fragments from this ship render, which we can see for the moment, anytime. And I want to use my fragments as a source for the debris. But here you can see that we have and the small fragments and the bigger fragments. So all the thing we have, I want to remove small fragments because I don't want to use them as a source because they're already small. So we can use the blast node to remove the fragments which have name as you remember, small pieces with a star. So we can remove all small pieces from our geometry and keep just the fragments. And the next thing we need to do is create like a threshold, which fragments or which geometry I want to use as a source. So I don't know why it doesn't work. Small pieces, guess from the points. That should work because I still have small pieces, which I don't want to have. I don't want to see them. Come on. Yeah, it's heavy for updating because there's like 700 megabytes per one frame. But also what we have, and I can't see this in the last, in our RBD week, is when we use the deforming node, some points left the geometry, and you can see that we have some insufficient result, like those primitives which have a very long, that's like a stretching. So sometimes 1 or 2 points can leave the main geometry because they have a maybe huge forces or maybe some huge impact, and we create some, like a very long primitives. And how we can deal with this. I open where's my scene? Here you go. So here my explosion RBD dynamic version 2, that's what we left on week 3, as you remember. That's what we have. And after the RBD deform pieces, let's look at the settings here. So we use our proxy geometry as the geometry for driving our main fragments, my main metal fragments. Yes, sometimes we have some weird results with this. And if you have many fragments or many primitives which have very long lengths, because of this deformation, we can play with settings. We can increase the minimum points, you can increase the maximum points, you can increase the radius for this, and sometimes it creates proper result. In my case, we have just a few wrong primitives, so I did want to recalculate all this thing. What I want to do, I want to remove those primitives. We won't see those deleted primitives from our render because it's just a few small primitives which was small, and then we stretch them because some points from our simulation they fly away from the base, from the positions. So how we can remove them? Well, there is very simple method, but it's not very simple. We should spend some time for recaching all the thing. We do need to go inside of simulation. I went back here to my RBD deform pieces and I create a new cache called deform cache. So I cache just my deformation pieces. So without other fragments or anything else, I just add the file cache over here on the path to the attribute delete. All right, and well, actually I can add this after the attribute delete, but what I want to do, I want to find which primitives became much bigger. How we can do this? Well, in fact, very simple. So I have the cache, and you can see that. Let me update this from the frame 36, for example, and let's look at our geometry. Again, this geometry without other elements is like main fragments, plus guns and antenna, but without small elements. So another way to use this deform cache is to put this cache to my this scene. So I do need to load my ship render cache with all elements and remove my small pieces. I can load this deform cache and this cache already without small pieces. So we do need to spend the time because this cache took like 500 megabytes per frame, while this cache take 700 megabytes per frame. So if we use the blast node, we need to load the whole geometry and then remove some elements. Except of this, we will load just deform cache. So that's one thing I want to do. So I can copy that. And let's transfer this here. And Houdini crashed again. Okay. So the deform cache is the same cache as our ship render without the blast. Okay. So we don't need to remove this. We can use this thing. So I can simply delete it. Okay. So again, but we still have some problems over here. Okay. It's not a solution for this problem, but we have this solution. All right, so also with this deform cache, I have the file cache and I load just frame 23 from the same deform cache file sequence. And this I call the rest frame. So this cache is just a static, position from my fragments before the explosions. So on frame 23, there's just my geometry from the ship, and this is some kind of a rest field, or rest positions from this. And what we can do, we can calculate the area for all our primitives here before explosion, before we apply the RBD deform pieces, before all those stretches and so on and so forth. So let's add a measure and let's leave it per element. And I want to calculate the same thing, the same measure for our deform cache in all other frames, let's say in frame 36. And I want to compare the area of each primitive in each frame after explosion to the size of the same primitives before explosion. Okay, there is a very important thing. If you want to make this thing works, you have to make sure that you have the same primitive number in both caches. In my case, we have the same because we use the same static geometry for deformation, F metal. So in all my frames inside of deform cache, I have the same primitive numbers because we're not removing anything. We use the same geometry, but we deform make a deformation for this geometry. That's why I know this. Here and here we have the same primitive number. In case we want to do this trick with any kind of geometry and we maybe remove some primitives, even if we remove just one primitive, it will break this, because when we compare this, it's comparing using the primitive number. And as you know, if we remove some primitive, I don't know, somewhere here in this list in the middle, so all primitives after this number will change, and we can't compare them anymore because they have a different numbers. So how we can do this, how we can compare those elements? Simply with the attribute wrangle. So you can set compare the area. So connect the first input to our main deform cache and the second one to our rest frame. I don't want to enable this, but by this time I will enable that after I add the expressions here. We want to work with primitives because we compute element time primitive. Yeah, we can't compute the, well, if you want to compute the area, we want to use a primitive, definitely. So let's calculate, let's create some attribute old area. Come on, old area. And I want to take from the second input, which had the index 1, as you know, the area from all primitives from my rest frame. So I want to use the prim function, and from the second input I want to take my area attribute by the primitive number. Again, that's why we should have the same number of the primitives if you want to compare them. So if our existed area attribute, which we calculate in measure 2, if I divide this existed area by the old area, and the result of this will be bigger than 2, so it means that if existed area will be bigger 2 times that my old area, because why 2 times? If we create the deformed pieces, we will have some stretching because our geometry, we applied the deformation for geometry. So we know that some primitives became smaller or bigger. And if we say that, okay, if we say the difference should be bigger than 0, we will remove many different primitives because, you know, we have a stretching at some level. But I think that there is not too many primitives which will increase the area 2 times, because, you know, it should be a big stretching, you know, if you increase the area 2 times. So in this case, if your area became 2 times bigger, then let's remove this primitive. By prim number, and the 1, which is, as you know, mean that we remove also the points from this primitive. And yeah, this is the brute force. It's very you know, brutal thing if you remove geometry. But again, this will work in 2 cases. If you don't have too many degenerated primitives, if you don't have too many stretchy primitives, because in this case you will remove too many geometry and this can, you know, be wrong in the render. So you need to play with the RBD deformed pieces, or maybe you add something wrong in your constraints and they became very big. Well, you know, the stretch is very big. Maybe you need to increase the stiffness, or maybe different setups for your constraints. Or let's play with RBD deformed pieces node. And then if you have just a few stretching, you can apply this method. So if I enable that and update, again, we do this all in the RBD dynamic project, because I remove this dynamic setup from my last project in Explosion. So what I need to do, if this will work, I just want to recalculate the render cache again, because I didn't want to see those stretched primitives on render either. It takes some time, but why I'm using the cache, in fact? Why I'm not just use the all this process again, why I create a cache and spend some resources. Again, this cache can help us to create sources for our additional elements. So I don't need to remove other elements because we add those elements in this stage before we go into the ship render. But why I create the cache, because it's very heavy. If we won't use the cache, I can connect like here to RBD deform pieces, this and this. I can create the frame, the time shift, okay, and freeze this on frame 23, let's say, connect to deform pieces and connect to measure. It'll be the same, okay? Connect this here, but it's really heavy because the RBD deform pieces, this node take like almost all my RAM from 32 gigabytes. Well, not all my RAM, like 24 gigabytes, plus it will calculate this thing, it will add some additional elements, my other geometry. But if you want to use this compare area process, you need to go to frame 23, calculate the RBD deform pieces from here, then calculate the current frame, and then combine those elements. So it took a very big amount of resources and a very, very big amount of time. So that's why I create a cache, and it's much, much faster if you just load two cache files, compare them, and write this into the ship render, merging with the other geometry. So I can connect it here. So can I see it? Why I can see? Let's update. Okay. And again, I can see why it doesn't work. I need to remove this primitive. That should work, but it doesn't. Okay, let's look at geometry spreadsheet and let's look in our old area. Oh, sorry, that's my mistake. That's why it doesn't work, because I typed the wrong. Okay, so because I should have the old area here, yeah, the old name, old area. Many old things we have, the name, the area, but it should work. Let's update it again. Where is my fragments? And here you go. We don't have those trashing stuff here, which is cool. All right, now we need to re-cache this stuff again. And I really can use this trick in my debris simulation, but I don't need to do this because of the principles of this simulation. The debris should be created just on the explosion frame. I don't want to create debris from flying objects. I can use my fragments, flying fragments, maybe for creating fire or smoke trails, but for debris, I'm interested in my fragments in the beginning of each explosion. So if you have explosion like on frame 25, 46, 49, that's where I want to create my debris, all right? So in this time, you can see there is no stretching, so I can use it. And what I should do here, how we can create the source for the debris. That's in fact very simple. There is a few ways we can deal with this. If we want to use fragments as a source, we need to separate which fragments should create those debris. And definitely the fragments is which actually flying away. Well, the static fragments here shouldn't create debris, just those elements. So how we can separate them? And the first source is velocity. If our fragment has the velocity, then let's use this fragment for creating something, smoke trail, debris, anything. But there is a few interesting things. The velocity is not a constant stuff, because the velocity can be big in the beginning of explosion, let's say for this part. But then this fragment will not fly away. It will move like 2 frames and then stuck in the same place. So it will not move anymore. So the big velocity for this fragment will be just for a few frames. Right? So how we can separate fragments which fly away from the explosions and continue have a velocity, or how we can separate which fragments will move from the explosion center. Let's say we have fragments on frame some like 46, 49, where we have the whole ship is moving up. We create the animation. So the big part of fragments have a huge velocity. We create this manually, as you remember, with animation. So they also have the velocity. So how we can separate which fragments fly away with the force and which fragments will move with an animation. Maybe the ship is moving, maybe it's not a ship, maybe it's a starship, a plane, and this plane already has a velocity. So we can't separate the velocity from the flying object from explosion and flying fragment inside of the object. Maybe this object moves too fast, maybe even faster than our fragments fly away from explosion. So in this case, we need to have a deal with a little bit of different situation. We need to understand which fragment goes out, is going from other fragments outside. So in this situation, we can make a very simple thing. The first thing, I want to pack the object. Why I want to pack the object? Because I want to create, I want to calculate the distance between fragments. So let's say if this distance is, I don't know, like a bigger than increasing, if this distance increase, it means that one fragment move from another one. So that's like a result of explosion or hitting or something else. Okay, so if all fragments moves at once, the distance between fragments will be the same. But if one fragment move in one direction and another fragment, his neighborhood, moves in another direction, it means that something happened. The explosion, I don't know, it hit something, anything else. So I didn't want to calculate all those points. You can see there is a lot of points, and I didn't want to create a distance between those points because, you know, with deformation, this distance can be changed. But if I choose fragments, the distance between fragments in a static position, or even if this object moves, all fragments moves at one direction with the same speed, and the distance between fragments without any interactions should be the same. But if you have the explosion, if you have some impact with another object, those fragments should move, and the distance between those fragments in the hit center or explosion center will be the different frame to frame. So that's what I want to calculate. I will pack this object, and we know that for the big fragments we have the old name attribute. That's what I want to use here. So let's enable checkbox, and let's change the name attribute from the name to the old name. That's what I want to use. It takes some time because it's really heavy model even without our small details. So if we look at the result of this packing stuff, we can see that there is almost 7,000 fragments as we expected. And now those fragments represented as the points. So if I remove geometry but keep the points, you will see just the points from which will represent each fragment of my ship. Here are those points. And we can simply calculate the distance between those points. And how we can do this? Well, okay, we can find the nearest point. We can use the distance command, but in this case, I want to make a very simple trick. I create the time shift, and the time shift I will make like a rest position. So maybe in frame 23 or 24, it doesn't matter. And this will be my rest position. So in frame 23, before the explosion, all my fragments will be at the static position. So there is no shifting, moving, there is no explosion. So even if this ship is moving, the distance between fragments or position of those fragments will be the same actually. So let's make, I know the rest position. And if this object is moving, we can also use the same method for the point deformation with the rest position and with the animation of the object. But in our case, our object is static, so it's a little bit easy. So let's go and add the rest position node. So let's say that I go to frame 36 like we did earlier. When we have some object which is moving over here with an explosion. So the required deforming I connect to my main geometry, and the rest position I connect to my rest shift. So if we look at our geometry spreadsheet, it takes some time for calculation. In our position attribute, let's go to points, I have a current position for all my fragments. In the rest, you can see that it's a little bit different. In the rest attribute, I have position for all those fragments, but on frame 23. So now I can compare those positions. And if this position is different, it means that our fragment is smooth. So what we can do is use the attribute WAP, and let's name it like a rest length. I want to find the length between our points, between our fragments. Well, our points, it is a fragment because we have the packet geometry. So if we want to find this, we can use the bind node. And let's say that I want to grab my rest position. All right, and this is the vector. And now I want to use a subtract. So the subtraction is a very simple method how we can draw the vector between 2 points. We can add 1 point for one input and another point to second input. I already show you how to do this, and the subtraction is actually the vector between those points. So now we take each point from the rest position and the same point from current position. And if we have a length, if this length bigger than 0, it means that this point will move. Okay, in our case, I want to use a bind export. Again, if your object is moving, you can do the same way, but before we use the attribute WAP, we need to add the animation for the rest position. So we already know how to apply animation. We use not here, we use a trick with I don't have ship animation. So we can now how we can apply animation. We already have the deformation for our fragments, so we can take our fragments without explosion, even if this object is moving, and compare those fragments without explosion. Also with explosion. Okay, but our ship is not moving in this moment. And let's go here and let's connect it to my bind export. Let's call this the rest vector, and it should be a vector. And we are on frame 36, so let's go to information and press rest vector. So now we have something colorized. I don't want to use the color, I want to use a vector. So right mouse button, you can see that there's, well, not very new option, but in the last version of Houdini we have a very good option here. If you press on this attribute, it will automatically add the marker over here. So we can simply just select this marker and add it. So except of the color, I want to use the marker, and except of the text, I want to use the vector. And now we can see a difference. So this vector show us how change position for those fragments. You can see that those elements will fly away from the center of explosion, or other elements have a very tiny or almost nothing. If you go to geometry spreadsheet, and for the rest vector, you can see that we have very small amounts for those points which will have no influence of the explosion. But we have those vectors showing us that between frame 23 and frame 36, we have a big distance which our fragments will go through. So now we can use those vectors to define which fragments will move and which fragments will not move actually. So go to attribute wrangle, and let's create a float attribute calling the rest, let's call it distance, and it will be equal to the length of our rest vector attribute. Okay, and now we need to say if my rest distance, oh come on, distance will be less than let's say 0.5. I want to remove point. So if my point or my fragment will not move too much, I want to remove it. Num. All right. So now we can see we left just those points which fly away in a big distance. All other elements will be removed. Cool. So now let's disable my add, because I want to look at my geometry. I want to look at my fragments. And that's a simple option how we can find the moving elements from our fragmented geometry. Okay. So what now I want to do is using the npack. I'm sorry, not here. And I want to leave just using the blast. I want to leave just inside or remove outside. So now I can have just the inside primitives, because I want to use those inside primitives for generating debris. But those primitives existing in all frames, because our fragments exist in all frames. But I want to remove my fragments from this simulation within one frame from the explosion. So debris should be created in the explosion frame. So there is a few option we can use here, and the most understandable option, I guess, is using our explosion frame. If we back to our explosion animation, we have, let's shift it here and back, we have our explosion frame attribute for each point. Over here you can see explosion frame 25, 46, 47, 49, etc. So we can take our points from here, copy it back to source from frags. I guess I can skip it. I don't want to calculate it. We already know that it works. Let's go to manual mode and let's add the object merge. Let's call this explo points. This can be helpful to rename your node, because sometimes when you have many object merge nodes and you can't understand which node, what this node exporting. And using the attribute transfer, I want to take, let's update this, because I want to have this attribute in the list from the point attributes. We can do this after unpacking, before unpacking, it doesn't matter in fact. So let's go to point, and we have the explosion frame. Let's say like, I don't know, the city, maybe even more, I don't know. It doesn't matter because I create debris closer to the explosion center, so I can use not a big distance threshold. So now you can see that every point, if you go to my blast and update, every point, hey, explosion, oh yeah, right, I need to select it here, explosion frame with transfer attributes. So any point from my fragments have the explosion frame, so we can see there is no like zeros or something incorrect. All right, and let's go to frame, I don't know, let's say 26. The thing is, I don't want to use the exact explosion frame, because in the beginning of explosion our fragments will not move too much. They begin to move in the next frame when they had the velocity or the force. So what I want to do, I want to, before the unpacking again, go to attribute wrangle, let's add this stuff here, and let's go and set the explosion frame will be plus equal 1. So oops, explosion frame plus 1. So if we go here, let's choose the auto update again, go to geometry spreadsheet, and in this case we should have the explosion frame equal 26, and yeah, that works. So now the next thing we need to do is creating the points in those areas. Where they are, here you go. So we can use the scatter. Okay, now let's go to attribute wrangle and let's set the simple rule. If our explosion frame will not be equal to current frame, then I want to remove point from the first input by ptnum. So in this case our geometry will exist just, let it update it, in explosion frame plus 1, so in frame 26, in frame 47, 49, and 50. Okay, so you can see we have this geometry in frame 26. Let me decrease the distance maybe to like 0.2, just for example. If it be very small, we can always make it bigger. So I can apply the scatter, but I want to use the density scale. So with the density scale we will produce points more accurate, because in the small elements will be the less points, in the bigger elements the more points, because we use the density scale. All right, so we have the points, and I'm going to use those points as a source for, let's say, the pop network. So my debris should fly away using existing velocity. But if you look at our velocity, it's empty. And it's empty because we not calculate velocity in the deformed cache. We calculate velocity for the ship render. As you remember, we use the trail sub for calculated velocity. And yeah, I need to do the same here. I need to use the trail sub for getting velocity, compute velocity. So now if you look at the frame 26, do we have a velocity here? I guess no. And we need to find out why. So it's back in reading geometry. Well, it's in geometry a few times because we need to calculate velocity between two different positions for each velocity in one frame and in another. Alright, so now we have velocity. Cool. That's what we should have, and this velocity is represented by the fragments which create those points. If you use the scatter points, it will automatically use the same attributes as our source. So if you have velocity in a source, this velocity will go to the points created from this source. So now if I apply let's apply the pop network. What I can do is creating the pop network. So to the simulation, let's use a start frame like 24 because there is no action till frame 25. So I want to have a little bit of gap between my explosion and the start frame for the pop network. Let's escape it because by default it tries to find some geometry. There is no surface, there is just a point. So go to source first input and let's choose it all points here. So it will automatically grab all points we have in input to the pop network, and it will use those points for getting the new ones, getting the particles, one particles based in one point. It takes some time. I guess we need to cache this thing, but we will do this a little bit later. Without recording, this thing works much faster, but we have what we have. I don't want to cache, each step, each node. So mainly is calculating velocity because for getting velocity we calculate position for 2 frames. And that's what we have. The blue points is the source, which is the guide, so we can turn this off. We already know that it should work in inherent velocity and the burst should work. So I did want to choose life expectancy because our debris should exist in every frame. It shouldn't disappear. So now I want to work with velocity because the velocity based on the fragments. So if we create points based on one fragment, the velocity from those points will be the same, exactly the same. So we need to add a little bit of noise or randomize, and noise and randomize. So before I do this, let's use the point jitter a little bit because I don't want to stack those points in in one flat surface. It won't look nice. It's a debris, you should, create some kind of differences. So 0.25 maybe. And let's look at that. Again, it's a bit dated. So, okay, let's use now to update because I really want to look at the velocities. So we should wait a little bit. I will use the pause for this moment. Alright, so with the point jitter, I will move those points a little bit. The cities doesn't matter because I will create those points just in one frame, so it doesn't matter what position should be in another one. And then I will add the point velocity. And that is a nice node which just allows us to create a noise for our velocities. So let me just go and set the manual because now each time when I change something on the point velocity node, it will calculate. So I keep in comment, so we're gonna leave the same velocity I have in input, but I want to use the curl noise. Let's scale it up like 5 and the pull duration. Again, it doesn't matter too much. Let's say 0.2. It doesn't matter because again, we use just one frame. Let's increase this wheel size a little bit, like 3 maybe. So let's update it. I want to look at my velocities. Is it correct? Is it exactly what I want or not? because I already have the scene ready, and I remember that something like this I add in my scene, and it should work in this, I hope, because as you know we create all from scratch. And come on, and here we go. So let's compare result. Oh, okay, let's back to auto update because it's hard to explain. Yeah, we can see the noise. And also I want to add the attribute random. So I don't like when I use the shift button, it doesn't connect this node with another one. Maybe we have some reason to not doing this, but so there's going to be velocity noise, and that should be velocity random. Cool, so let's add a v because I want to add a velocity, and I want to not to set, I want to multiply and use the cast ramp. So I want to fit, set the minimum and maximum. So I'd want to use a 0, so let's say like 0.15 or 0.1 maybe, but 15 could be good. And let's change, I want to get away, make more like bigger velocities value and less smaller values. So this is our random, and before we go to pop network, I really want to remove something useful. So attribute delete, maybe we have some attributes we don't want to see at the pop network. And yeah, the pop, actually those points will not use for render or something else. So I don't need the texture, I don't need the curvature, explosion frame I need anymore, rest position, I guess I don't need it. Well, if I will need the rest, I can always get back to attribute delete and, you know, remove here from the list. So now with the pop network, I have the particles which moving from the center of explosion. They use the velocity of my fragments, and in this case I should have fragments on frame 26, 47 and etc. So let's change it to like, I don't know, to 60, from 23 to 60. I want to look at the dynamic for my particles. Is the velocity correct, or maybe I should create a bigger scale for velocities? I can do this in the pop network, or I can do this in my points before the pop network. We can multiply it. So there is many different ways to do this. So let's wait a little bit and look at the result. And here the result, and it works as I expected. You can see that we generate particles in the next frame for the explosion frame, on frame 26, and frame 47, 50 and 51. Bam, bam, bam. It works fine, but our particles fly away too fast. We definitely need to add a little bit more drag, because it should have like an air resistance for the small object. So we need to apply some dragging option. Also we need to add the gravity for those. So let's go to pop network and select here, add the gravity. The first thing we need to add here, because the gravities should work if we want to represent simulation existed in our planet. Okay, let's remove this merge. And what I want to add here with the source first input, I guess that I'm gonna leave this by default. I'm gonna use my all particles. Let's just go to manual. I don't need to change nothing. I guess the velocity is fine. I don't need to make it bigger or smaller. What I really want to do, I want to set the pop drag, and not too much, maybe like 0.01, because it's really very, you know, sensitive parameter. Also, let's add some let's add some variation for the resistance. So this parameter called parameter, you can see air resist. So let's type air resist to resist. 2 times s, I guess. No, air, no, 1 time. Okay, air resist will be equal to the random function by the point number, and also want to use the fit O1 function. Come on, something wrong with me. So let's make a little bit of gap between 0 and 1, because I really don't want to have a 0 A resist for points because they fly away too much. So let's say maybe you can use a multiplication. So let's multiply it by 0.9111. So it means that 10% smaller or 10% more over here. And also if the position, so position that y, which just means that I want to take position from the y-axis, will be lower than I don't know, maybe 0.1. The A resist, let me copy this guy, will be equal to like 0.25. Okay, so we slow down my particles more and more. And then I'm gonna use the pop kill, because with the gravity our particles will fall down. I don't want to have particles somewhere deep under the water because I won't see those particles. So I want to set the rule if the same thing position in my y-axis will be smaller than -5, 5, then you need to add this particle to the dead group. So the dead will be equal 1. And we kill those particles. Well, let's look at this. Let's simulate it. Oh, I guess that we need back here and switch to auto update. Again, it takes some time, but I hope it will be enough. Let's stop it, go to first frame, and again I want to look at the flipbook, press start and make a pause. So now I have a much more difference. So now my particles fly away not with the same speed. We have a little bit of resistance. It's looking good. So, and but this is just the particles. We need to create a geometry around those particles. And to do this, let's add the file cache. Well, let's my file cache, just a file. I want to take my geometry from the export and the debris. I download from internet a few debris assets and combine as a debris BGOSC. And here we have an asset, just a bunch of elements. So what we need to do, if I want to use those elements as a debris for each particle, I need to separate them. You can see that there is 8 packed alembics. So each of those fragments is a separate object. So I need to take each of this object and replace with the actually take each particle from the pop network and replace with one of those objects. So before I do this, I need to move each of this object at one point, because you can see that if we take this object, the pivot point will be here. So if we apply the rotation for particle, this object will not rotating through the center, it's rotating around this point like here. So it won't be very good. So we need to move all those objects at one position here, at the 0 position. So how we can do this? Well, actually we have a name for those objects. I know what is doing. I don't need to select my deforming. Maybe somewhere no, this works fine. So we'll go to first frame, and we don't have a name. So let's just use the for each primitive, because we have innate primitives. So now when I select for each begin, it will show me the first object. Here you go, this nice banded metal. So the first thing I need to do is unpack my object, because if I want to apply something, in fact, maybe without unpacking, let's do this. So let's try to apply the transformation. So go to transform, and what I want to do, I want to use the centroid for this element. So let's type centroid, and let's take our, let's drag this stuff here. So I want to take my for each begin as an object for centroid. Then in parentheses I need to select the object where I want to drag the kind position. You can see that centroid function works in the parentheses. We select the object, and then we need to find the axis dx in my case if I want to apply centroid for x-axis. So if I select this, so what is wrong? I forget. Oh, come on. It's a little bit dark here, so I can make a mistake. So now I can see that this object is moving away from the point, but I want to go to the center of this point. So I need to add a minus centroid. In this case, it will move this thing into a 0. So the same comment I want to copy and add to the y-axis and to the z-axis. So now this object in the center. If I apply this transformation for each primitive, now you can see that all my elements in the center. Okay. All right. So now how I can take my points. Let's go somewhere to frame 26 where I have something from my pop network. And let's apply copy to points. Copy to points is a very fast thing. So in select copy to points, now you can see that all my points will be replaced with those elements. But what I want to do, I want to select the piece attribute. So now you can see that for each point we grab all our objects, but I want to take just one object. So what I can do is set the attribute triangle and create some kind of element. So I create the integer attribute called element, and this element will be the random function for each point based on the point number. But if, as you remember, the random value creates value between 0 and 1, but in this case it will not go to 1, it will not produce 0 and 1, it will produce values between 0 and 1. That's why it will not be 1 anymore. So you can see that my element is just 0. But if you go here to my for each, you can see that we have together 8. This means that we have 8 pieces. So if I multiply my ptnum or multiply my random value by 8, it will produce the 8 elements. So the smallest one is 0, the biggest one is 7. Yeah, because 0 is 8 elements. 0, 1, 2, 3, 4, 5, 6, 7. All right, and now inside of the copy to points, I want to use this attribute element. Come on. Element. Without S, element. Right. to copy to points. So what is wrong here? Oh, I forget to set that it's an integer. So now, do we have a difference or not? Yeah, we have a difference. But anyway, we definitely should create much smaller scale, because each of those elements like almost 25, even more, like 25 meters. So we need to add the p-scale attribute. So add the attribute wrangle again. So set element, and let's set the p-scale. Set a p-scale. All right, so here I want to add the p-scale attribute and change it, because I want to have like a different p-scale option, not the same p-scale for each point. So let's do this. We can work with variable or we can work with attribute at once, so it doesn't matter. The p-scale attribute will be equal to the random, again by ptnum. We do this many times, and let's make let's add a fit 01, and let's make a difference. So I really don't know, say 0.11. I don't know which scale I want to use. So now with the p-scale attribute, go to copy to points up. Now it's much smaller, should be. So let's set now 03. Still pretty big. Okay, let's, I don't know, we can use like a multiplication. So p-scale multiply, I don't know, like 0.1, so 10 times smaller. That's much better. Let's look at the camera. A tiny bit smaller. 0.75. I want to use a ramp. So p-scale will be equal to channel ramp. And let's call this p-scale. P-scale, and I use a p-scale attribute. P66. P-scale attribute. Okay, let's add the channel ramp, and let's make B-spline for all points, and for you also, and make it. So as you know, if you create the fragments, there should be a few elements with a bigger scale and many more elements with a smaller scale. I don't like the concentration in this area, so we can go somewhere here on the blast. Let's wait a little bit. All right, and I want to remove this huge element. So let's select this. Let's remove it. Okay. Oh, that's much better. We can leave some of those. Oh, we can definitely remove it. I just want to look at the area for those objects. It definitely should have a big area. I remove and add packet to a triangle. There's no area attribute. So let's set, I just want to look at that. Let's set the measure. for primitives. So per element, primitives, fine. So where's my area? Oh, primitive, sorry, I'll look at the points. So if I look at here in the blast and go to area and look at the biggest areas, yeah. Okay. So what I can do is say that let's remove, let's do the next thing. Let's add NAS blast. And if the area will be bigger than, what is the biggest setting here? 2.5, bigger than 1, let's say, bigger than 1. Primitives, let's remove it. So we remove some of those elements. Let's look at, yeah. Let's look at that. I just want to make sure that I'm not removing something useful. Okay. So my 0.3, yeah, that's the last thing I want to do here. Because maybe in the next frames we will have a nice primitives with such an, okay, so that's like a more procedural. Now let's back to our copy to points. This is my element. So what I need to add here is the random orientation. So let's add the random attribute randomize, and let's set the normal. I want to randomize my normal. So I don't know. Doesn't look correct. Contain direction or orientation. Yeah, that's what I want. Right, but it's just direction for the normal. So if you look at our points and select the normals, it will move with the same normal. So the normals won't be changed. So I need to add a spin because those particles should rotate around the axis. So to do this, I can go to the pop here and add some kind of the pop spin. And a pop spin. Come on. Oh, come on, guys, I can stop it. Let's go to a manual. All right, so the pop spin can have a spin speed. It also have the axis. So what we can do, we can set the spin speed like, I don't know, 180. So it's like the spinning speed is the degrees in degrees per second. So how fast it should spin. But again, if they will rotate with one axis with exactly the same speed, it won't be very interesting. So I want to change the axis. So axis is have the same name, axis, and the axis will be equal to random by IDs, because we have an ID number, is unique ID for each point, and minus set, that's a null function actually. I used that function for many years. 0.5, 0.5, 0.5. So that will create the random values between between 0 and 1, and then we minus 0.5. So it will create random values between minus 0.5 and 0.5. Then I want to change the spin speed for each fragment also. So if we look at the name is spin speed, and I want to take the existed speed and multiply by the same random function pt9, just add some random value because I didn't want to have the same random like here. Oh, sorry, ptnum id, yes. ID, yeah, Control Enter. So now let's go to copy 2 points up and let's go to auto update, select my camera, and I want to look at the debris simulation. Do I need to correct something or not? Slow in geometry, so I make a pause and make a flipbook. And that's what we have with the debris. Guess that we can increase rotation a little bit. So 120 degrees is not, well, it's not bad in fact. We can try to increase it. As you can see, I create the cache. I save it into the file cache here. And that's how we create our debris. Yeah, definitely does increase a little bit of rotation. I just launch Houdini again. Where is my pop network? Let's go to a pop spin. Let's get to 360. Again, if it will be bigger, more than I expect, can reduce it to 140, something like that. And another thing I did, I disable attribute randomize normal here and add this randomize before before the pop network. And the reason for this, because we create spinning inside of the pop network and then applying the normals, which will remove our spinning because it will apply the normal like a static normal for all points. Okay, and then that's why they're not rotating there. So without randomizing the normals, all our elements looking in the same direction, and it's looking not very good. So before I add to the pop network, I change the direction and orientation for the normals by the point, and as in always, our pop network will apply the same direction for all particles. Alright, so now it's looking really good and we can save it. You can say add a null object. It's not necessary, but because of debris, because we're gonna send this debris render into the separate files, which we will use for the rendering. So the version 1 created debris. The next thing we need to add here is, we can call it the smoke or the fire trails. So what we need to do, we need to take the same elements, the same fragments flying away from the explosion center, but in this case we don't need to apply our explode points because they should create the fire, or they should generate the source for the pyro simulation in the all in the all path they fly or they move. So we don't need to remove this as a source using the explosion frame, but also we can try to use almost the same setup to work with the pyro. So we're going to save it as the version 2 and we're going to work.